Hi, I'm Barry List for Informs, and you're watching the latest in an online series about the best ways that your organization can use analytics. Today's special segment is devoted to big data and high-performance analytics. Our guest is Radhika Kulkarni, Vice President of Advanced Analytics, R&D at SAS. Radhika, thanks for joining us.
Thank you, Barry. Thanks for inviting me to talk with you about this subject that I'm very, very passionate about. As you know, I head up the Advanced Analytics R&D at SAS, and my team is responsible for providing analytical algorithms to solve complex analytical problems. The mantra at SAS is that no problem should be too big for us to solve, and so naturally the big data era that we are in today gives us some really wonderful, exciting problems to solve, and I'm excited about that.
Great, and let's talk about big data, and let's begin with a definition. What is it, and how do you relate it to what's known as the 3 V's?
Okay, the 3 V's that Barry, you're referring to is volume, variety, and velocity. Big data, the way we define it, is whenever the data sizes exceed the ability for your organization to handle, store, and analyze data beyond the current capacity, we call that big data. So it's a relative terms. What's big data today may not be big data tomorrow because computer hardware is just growing in leaps and bounds. So the challenges sometimes arise because you may not be able to fit all your data in one hardware platform or in one node or one computer. At other times, even if you are able to fit the data, the CPU required to solve those problems are immense, and you really need to take advantage of multiple cores to solve that problem. So big data big data problems could arise from whether the problem size or the complexity of the algorithms needed to solve it.
And why does it matter? Why has it become such a big topic in tech and analytics circles?
It's a good question. The problem sizes, the data sizes are just growing in leaps and bounds. The type of data that your organization needs to solve, to handle, the types of problems that you're trying to solve, where you've got multiple constraints from all over, and the need to squeeze out every little bit from whatever you can do with and get the best insight is just immense. So the types of volumes of data that we're talking about are in terabytes and petabytes, and that's a huge amount. For example, a particular retail marketing service has data available for just weekly data which extends to 2.5 petabytes of data, and then every week you add 300 million observations to that data. So being able to analyze that volume and gain meaningful insights is very, very valuable.
How do we deal with big data, and what's the role in this for something that you call high-performance analytics?
Big data, we've been used to distributing our computation in multiple ways for a long time, especially in OR. We've got threaded solvers and gridded solvers and so on and so forth. What we typically tend to do is break the problem down into small chunks that can be palmed off to different nodes in a compute cluster. What's more challenging today is that the data sizes are immense, so even they cannot fit on the different cores of a particular one single hardware platform. You might need to use a distributed environment, and you've got data sitting on multiple locations. You've got some massively parallel databases where a lot of data is residing in the databases, and you don't want to really move them out of the database. So you need to be able to solve the problems by moving some of the analytical algorithms to where the data resides. And that's where a big new era of computing technology is coming into play. And a big part of what we're doing right now is figuring out how we can use the massively parallel databases as not just a storage mechanism, but also as a compute platform. So how can we use the extra capacity in those databases to actually put some algorithms down there so that you move the data in memory and then solve the problems over there.
And how do we make this all happen? If somebody is a business person who's looking at big data, how do we make it happen?
by looking at the type of problem you want to solve and what are the types of algorithms you need to bring to bear. Often, some of the challenges come out because the standard techniques that might be very, very useful in standard problems are no longer valid when you've got memory that's across multiple nodes and multiple hardware platforms. You need to sometimes invent new techniques so that you can solve these problems in this new environment. So that's where, it's a great, exciting time for all analytical people, I believe, because there's new challenges, problems that we found a traditional way to solve them no longer may be possible, so you need to find new techniques and new algorithms to solve those problems.
Can you give some examples of the business benefits of using high-performance analytics?
Yeah, so some of the business benefits really derive from the fact that by using high-performance analytics, you can take down the time it takes to solve a problem from several hours down to minutes and sometimes even seconds. So what does that give an organization the ability to do? What used to be possible, you would say that, okay, you send off this data, do the analysis, and come back over the weekend and give us one result. And you had to make do with that particular result. So if you're building a predictive model, for instance, often when you have multiple predictors going into the model, you might have to come to settle for a set of variables that you're going to use in your model. And so you run the analysis and come back after several hours and use the result. But if you're able to do the same analysis in a few minutes instead of many, many hours, you could say, okay, if I were to drop out some of the variables, if I were to add a few new variables, can I get a better lift? Can I get a better model? And those are the types of game-changing situations that you're able to be in, because now no longer do you have to wait several hours and live with the result that you get, but you can actually do your analysis multiple times on the fly. You might be in a board meeting and you've just decided that you've come up with the marketing optimization campaign results, but the executive director or some campaign manager says, hey, you know what if we increase the budget today? Could we get a better lift, or could we get a better set of optimal campaigns? And you can run the analysis right there, and within a few minutes you get the results. So that's the kind of change that is possible by enabling us to use the compute structure of a multiple hardware system and use game-changing analytics to solve the problem.
Final question. Retailing is a huge area for big data. What are a couple of ways that retailing in particular benefits?
I can take a couple of quick examples. There is a retail marketing service, Catalina Marketing, that we work with, and what they do is create coupons behind, when you go to any grocery store and you buy something and there's a point of sale data and you get a receipt. On the back of the receipt, you might notice that there are many offers that are customized, that seem to be customized to you. Where do you get all of that? That comes from building predictive models, which take historical data and your current transaction data and give you some coupons that are most beneficial to you. In order to do that, you need to build lots of models beforehand and then use that insight right there and then. So by using these high performance analytics, this particular company is able to reduce the amount of computation time significantly from several hours to just a couple of hours and get a better lift out of this modeling process. And another example is a markdown optimization problem in a fashion retailer, where you're trying to create a markdown clearance price index over several weeks as you want to run down your inventory by the end of the fashion season. And there again, the pricing decisions that you need to make are as many as like 270 million pricing decisions every week, and you have a weekend window when you need to run the forecasting, the estimation, and the optimization to come up with the optimal prices. And in order to do that, it used to take them several hours, and they may be able to get one run to meet the service level agreement for that retailer. But now by using the high performance markdown optimization, they're able to run it in reduce the time from 30 hours down to 2 hours. So you can imagine the kind of insight they can get by being able to run multiple scenarios. So that's the kind of benefit one gets by using these high performance analytics engines.
Thanks, Radhika Kulkarni of SAS. And thank you for watching this quick take on Analytics from Informs, the Institute for Operations Research and the Management Sciences. For more information, visit us on the web at www.informs.org. Thank you.